question on radioactivity now. So an atom of carbon has 6 protons and 8 neutrons. We're being asked to identify the correct row in the table for an atom that is a different isotope. So remember, the definition of an isotope is that we have the same number of protons, but we have a different number of neutrons. So we need something that has still got 6, meaning it's either A or B, but now we are looking for something that's got a different number of neutrons, and the only one where that is the case is A. Which type of radiation is a high energy electron? That is beta. Here we're being asked to identify the type of radiation emitted when the mass number has decreased by 1 and the atomic number has stayed the same. So with alpha radiation, our atomic number goes down by 2 and our mass number goes down by 4, so it can't be alpha. With beta, our atomic number will go up by 1 and our mass number will stay the same, so it can't be beta. Gamma is a wave, and therefore there is no change to the physical structure of the nucleus, and therefore when we look at the idea of a neutron being emitted, a neutron would cause the atomic number to remain the same, because the atomic number tells us about the number of protons only, and the mass number tells us about protons and neutrons, so the answer here would be a neutron emission. If we look at this one, we're being asked to identify how many electrons could be in this uranium ion. Now remember, an ion is a charged atom, so we're looking for an atom where the number of protons and the number of electrons is not equal. So we therefore know, because this has got 92 protons, we know that it cannot be B. Okay, in order to have a positively charged ion, we know that we must have more protons than we have electrons, and therefore the only option that works here is option A, which is 90. Now we're being asked to calculate the activity of an isotope after 16 hours. We're told that the half-life of that isotope is 8 hours, and we're told that the initial activity is 400 becquerels. So the first thing we need to do is say, okay, if 16 hours have passed, how many half-lives is that? Well, if one half-life is 8 hours, then 16 hours must equal 2 half-lives. So what that means is that we can do this two ways. We can either say, well, okay, if we start off with 400, we can divide it by 2 the first time for the first half-life, which gives us 200, and then we can take that 200 and we can divide it by 2 again, which will give us the 100. So there is option 1. The other way we could do this is we can say, well, actually, after 2 half-lives, we know that we are left with a quarter of the original remaining. So either of those methods will work absolutely fine, but either way, the answer then becomes C.